Hi there, YouTubers. Hey, my wife and I have just finished retrofitting this 2010 Polaris EV with lithium batteries. And we had lead acid batteries in there, and now we have lithium batteries. And I made a lot of little short videos as we went along to capture every detail of how we did it. But the resulting YouTube video would have been too file intensive and too long. So this is just an introduction, and I'll try to piece together segments from the smaller videos that I made with some detail here and there about stuff you might want to see. And it'll be pretty fragmented, I'm sure, but I apologize for that, and I hope you get something out of this video. I decided to use lithium iron phosphate batteries, LIFPO batteries, but they are lithium iron phosphate batteries, and I only wanted to use 4 of them, and I wanted to buy them from this company because I think the people from the Dakotas are quite reliable, decent people. I did not buy the set of 4 for $2,099 that you see here. I bought a better type. Our Polaris originally had 8 of these Trojan T-1275 batteries. These are lead acid batteries. They weigh 82 pounds each, and they're only warranted for 18 months. And as you can see, they're quite expensive. That's a set of 4, $1,528.99. You would need 8 of those. A couple more things I want to mention about the Dakota Lithium brand of lithium iron phosphate batteries is that they have plastic housings that will not rust. They can be mounted in any position, upside down, sideways, or whatever, and they're not going to leak. They have brass hardware and connections. I had nothing but problems with my lead acid batteries. The water would boil over as I tried to charge them with the onboard charger, which, by the way, is no longer compatible with lithium iron phosphate batteries. And I had nothing but corrosion. Sometimes the terminals would burn right off of the batteries, and I would have to replace them with a stainless steel hanger bolt that I would screw in after I drilled a hole in the remaining lead. It was awful. These Dakota Lithium batteries, this set of 4, is intended for a 48 volt golf cart battery system. They have free shipping, they have an 11-year warranty, they have a free 48 volt charger. In fact, what I received is a 48 volt charger and 2 12 volt chargers. That particular price that you see there is for the 60 amp hour version. However, if I click on the 60 plus miles version, miles being for a golf cart, now the price is $4,499. So they are very expensive, but they are Class A batteries, and that means that they are very reliable and built to very demanding specifications. And these batteries only weigh 27.2 pounds per battery times 4. That means my Polaris is going to get over 500 pounds lighter by going from 8 lead acid batteries down to 4 LIFPO batteries. I need to make a little correction here. Earlier in this YouTube video, I stated that one would have needed 8 of the lead acid batteries, the Trojans. Well, actually, I suppose one could have gotten by with 4 of the lead acid Trojan batteries, and I did think about that, but I was just so tired of the corrosion problems that I wanted to try the lithium iron phosphate technology. What follows now in this YouTube video will be a few photos that show the corrosion problems I had and how I had to replace some of the studs that melted right out of the Trojan batteries. Well, I got two boxes like this from UPS, and I assume each box contains two batteries, and I'm hoping there's at least one battery charger in one of these two boxes. The UPS guy said they weigh about 57 pounds each, which would be about right if each battery is 27 pounds. Let's see what we got here. Looks like we do have a charger, 48 volt charger, and each of the batteries seems to be in its own box, so we'll pause the video here. There's hardware in here, various kinds of terminals, and I'm excited about that because on my lead acid batteries that I had in my Polaris, it would melt the terminals completely off the battery, and that, believe me, was pretty disgusting. That's all for now. Well, I opened the second box containing two batteries, and it also contained two 12 volt battery chargers. I was a little surprised to see that. Now, just a little bit of clarification here. This 48 volt charger is actually for an input of 100 to 240 volts. That's pretty amazing. 50 to 60 cycles per second. The output will be 57.6 volts, 8 amps. And apparently it will have red and black leads on it. The other two chargers are also 100 to 240 volts and 50 to 60 cycles per second, and the output is going to be 14.4 volts, which is perfectly adequate for a 12.8 volt battery. All right, I've installed two of the four batteries. They're not restrained in any way, but they're in there. And they're positioned such that I can use short cables to connect them in series. And what I'm going to do now is use both of the 12 volt chargers that came with these batteries and charge each battery individually, because the instructions say that these batteries are shipped with only 10% charge. So I'll do that now off camera. Alright, I have fabricated a wooden hold down which keeps the batteries nice and straight and separated by a proper distance, and I will end up putting these studs. I'll drill holes and I'll put studs down through. They're stainless steel studs, so they shouldn't rust, and that will be done on both sides. That is to say, to the batteries on the other side as well.
Okay.
What I've done is I put both batteries in, which means that this was way up. Then I got the center one going. I put a hole down through the floor, down through this, and there's a steel panel underneath. So I put that one in, and then I subsequently have done several. This one didn't work out because there's a steel channel underneath there. And the first thing I would do then, I have one left to do here, and I will go back in here and I will drill down through. And I have to be careful because there is a channel going through there. Once I have drilled down through, I will use this 1.5 inch bit from underneath, because there is a plastic skid plate under there. And once I have the small hole going through, I will know where to drill with this one and have wrench access to a nut on the end of that steel rod, stainless steel rod I should say. The original charging system had a light that would indicate, among other things, when the batteries were fully charged, but that won't work anymore because it was connected to the original charging system, and I will be using a new charging system. The new charging system will be located in this area, and there is a side panel that goes here, and originally it had a bezel, I guess you'd call it a bezel, and the center part of that bezel was filled in with a symbol that indicated that there would be no fuel added. This is apparently where the fuel tank would be and the fuel fill would be on a gas-powered Polaris. So I machined that out on my lathe, and what I plan to do is put the charger, the new charger, down in this area. Now this charger has two lights. One indicates that power is on. The other light will indicate red until the batteries are fully charged, and then it will indicate green. Well, I need to position that in this area, and of course I will be able to pull the plug out through this hole in the bezel. So I'll be able to look down in there and see if the light is green, and I'll easily be able to pull the plug out, the cord out. Well, we've completed the structure that will hold the charger, and I'll put the charger in there now. I will have to come up with a bit of a tie strap technique, I think, for holding the charger in place so it won't be moving around, but it does position the charger so that the cord can easily come out through that hole in the shroud, and we will easily be able to see down through the hole in the shroud, and we will be able to see these lights. So we think it's working out rather well. And by the way, we tried the shroud on here and it does clear. And I want to acknowledge my wife, Carolyn, who has been helping me a lot on this project. Thank you, Carolyn. So as I mentioned before, I will be mounting this charger, which has two lights. I'll be mounting it down inside in a position that will allow me to see the two lights through this little opening here. And this little opening here had a pop-in bezel, which I bored out, and I've made this Osage orange knob, if you will. And what's going to happen is I'm going to have a wire down through there. This will be glued, this walnut piece will be glued in there such that I can readily, of course the wire will have to be formed in such a manner that it will hold and pull the cord out through the hole, the cord plug out through the hole, and so in other words, I'll pull this out and I'll be able to see the green light when the charging is complete. We'll see how this all works out, and I'll show it a little later in the video. When I first received the lithium batteries from Dakota Lithium, I charged each one of them individually all the way up using one of the 12-volt chargers that they had sent with the kit. And then this battery condition indicator did read full charge immediately after that operation of charging them separately. However, I've taken a few little trips and now the indicator is down, and even though I have charged them all the way up with the 48-volt charger, this indicator is still indicating rather low, so I won't be able to rely on that indicator at all. Since this voltmeter or battery condition indicator is no longer working well, as we can see here, it's showing a fairly low battery condition, even though my batteries are fully charged. That comes on with the ignition switch and it goes off with the ignition switch. But what I'm going to do is I'm going to put in a digital voltmeter, which actually the previous owner of this Polaris had bought because he knew that the existing one wasn't very good. This has leads on the back, and I have fabricated a little bracket, which is nothing more than some aluminum sheet metal and a piece of plexiglass that I bonded to the back of the sheet metal, and this will eventually be installed underneath this isolation mount for the windshield to keep the windshield from rattling. So it'll be presented in a nice visible fashion here. But it occurred to me that the digital voltmeter would be on all the time, so I purchased a momentary switch. So whether the key's on or off, I can push this button and I can see what the voltage is, okay, on the digital voltmeter. Now I'm going to attach this momentary switch into an existing hole that's right above the ignition switch. I took the rubber plug out, and the plan will be, I found some washers in my extensive collection of old washers. I found a couple washers that fit pretty well and still leave room, well, I dropped it, still leave room to put the nut on there and have enough space for that plastic shroud there. So that's where I will have the momentary switch to turn on the voltmeter at will so that I don't forget it and let that voltmeter run for weeks at a time when I'm out of state or something, and run the batteries down. Well, the installation of the voltmeter and the installation of the little button, the momentary button, went really well, and it works really well. So we're pretty happy with that. And I'll do the underneath side and the bolt and everything. When I first got the batteries, I saw this little card, and right above my thumb there you see used dielectric grease. Not sure that's even spelled right, but then I applied the grease to everything, even the conductive surfaces. And then I started reading the Dakota Lithium instructions and so forth. It does say use dielectric grease, but down here it says do not put grease in between the primary mating surfaces. And of course I did. But I'm going to leave it. The worst that can happen is I'll lose conductivity, and then I'll realize that I have to take the dielectric grease out of the conductive surfaces. By the way, notice the spelling of dielectric right here, which appears to be correct to me. I have been using the Polaris for a few days, but I have encountered a problem. The Polaris has 3 driving modes, which are low and high, and the M is not for medium, it's for maximum distance. So I was operating in medium and low, but never in high. Well, then I decided to try high, and I was on a gravel road and I went full speed for about 200 yards and it just stopped. And I suspect that the 150 amp fuse that we see right here that came with the Dakota Lithium batteries, I suspect that that has blown. So what I did is I took my voltmeter, my old Radio Shack voltmeter, and I hooked the negative lead to the negative terminal of battery number 1 in series, and I checked each battery. So I had 12 volts, then 36 volts, and then 12 volts, then 24 volts, then 36, then about 48 or 50. And if we touch this terminal, we have about 50 volts. On the 10 scale there, it's about halfway up, 5. But if I move over to the downstream side of this fuse, I have nothing. I have nothing. Now, interesting, there's a little bit of continuity through that fuse, even though it is apparently blown. And I tested that with my resistance feature on the voltmeter. Anyway, I wrote to the folks at Dakota Lithium, and the guy, the very knowledgeable guy in the service department, said that since I have a 250 amp fuse in my Polaris, I can eliminate this 150, and that's what I will do now. So we're just getting ready to do a speed test in all 3 driving modes on the Polaris. I would not say that the batteries are fully charged because I was not able to charge them when the fuse had blown. And well, anyway, we've got pretty good voltage on the voltmeter, so we'll give it a try. We're going to use an old GPS to see how fast we're going. Well, the speed test on a fairly level gravel road is complete, and in the low speed mode we got 11 to 12 miles an hour maximum. In the high speed we got 23 to 24 miles per hour maximum, and in the M, which is maximum range mode, we had 14 to 15 miles per hour. And now that we're back home, we can see, let's see, 52.9 volts. 52.9 volts. That's pretty amazing. I gotta say that this performance is nothing short of extraordinary, and I'm very happy with it. Also, in the next portion of the video, you're going to see I'm driving at maximum speed and high range. And to be honest, the Polaris gets a little squirrely on the gravel road, so I wouldn't really want to go much faster than that. But it does go fast. And I even took it down to our gate and started to drive home in the same area where the fuse blew the other day. And I went at maximum speed and high range, and it worked perfectly. So now I'm going to demonstrate how we charge the Polaris with the new batteries. And sorry about the cord, it's pretty terrible. And you can see that the lights are visible down through the portal. And that's working out pretty well. And sure enough, now I can push the momentary button for the voltmeter, and I have some indication of voltage, whereas before I did that direct connect eliminating the fuse, I had nothing here. I had nothing at all there, and I had nothing when I would turn the ignition switch on. Now I get some action when I turn the switch on. I gotta tell you that I had disconnected the negative terminal on the first battery before I went to work and changed things here to eliminate the fuse, and there is a heck of a spark when you connect the final terminal to the 50 volt DC system. Don't let that alarm you, it's normal. Well, the instructions that came with the Dakota lithium batteries indicated I should use a dielectric grease on all of the connections to eliminate corrosion. So my wife got me this tube of Gunk brand grease and this nice pink cosmetics brush. She paid $1 in the women's cosmetics section, and I didn't know you could buy anything for $1 in the women's cosmetics section. But even though I'm a manly man, and you know that from how dirty my fingernails are in some of these videos, I will use that pink brush. Well folks, we went 18.2 miles and I could not detect any drop in performance at all, and the voltage was still something on the order of 50 volts, very good voltage and performance. So that's plenty for us. I mean, that represents many days of driving around our acreage. And so even though there was probably a lot of energy left and I could have gone many more miles, I decided to charge the batteries anyway. It did take a long time to charge the batteries. I think I charged overnight and it still was not charged, and then we had to go on a week-long trip to another state. So I finished charging when I got back, and that was also an overnight deal, but it was charged up by the next morning. I had a failure at about 18.2 miles. I was coming home and I decided to try that high-speed mode again, and I was going fast, and all of a sudden the Polaris just stopped, and I thought that I had blown the 250 amp fuse that is in the system, but I checked that fuse out, and that fuse was fine. I still had about 50 volts on the voltmeter, and now after charging I have 53.4 volts. It's fully charged now. But anyway, I checked out that fuse and it was okay, and then I started to be fearful that I would either have to replace the solenoid or the whole controller, and those are very expensive components. But after I fiddled around with it a while and loosened some connections, and I did replace a couple washers that were corroded, and now the system works just fine without changing any components. So I will just have to kind of take it easy on this Polaris. So I hope that I don't have a repeat failure like that. Well folks, the bottom line is I am very happy with these lithium batteries. I did have a little problem and I described that in the video, and I don't know what the problem was. The bottom line there is I fiddled around with the system a little bit and it worked just fine afterwards. So my conclusion is that anytime I have that system stop like that, I'm going to disconnect the negative terminal to the whole battery system and just see if the controller will reset itself or something, and it will work just fine. But I did purchase a 250 amp breaker so that if I have that problem over and over again, I will put the breaker in so I can easily reset. So once the circuit is broken, it's a simple matter of resetting. So I will deliberately break the circuit and wait a while and remake the circuit and see if the system has corrected itself. So bottom line, I'm very, very happy with the lithium batteries, and even though it was very costly, I'm happy to have made this purchase. That's all.